day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tapang Mapotsani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, in today's lesson, we're going to focus on financial mathematics. The topic is allocated 15 marks. Our topic for this content area is finance growth, decay and annuities. The subtopic we're going to deal with is present and future value annuities. Lesson objectives. By the end of this lesson, learners, you must be able to use the present and future value annuities formulae. The formula are as follows: F is equals to X open bracket, open another bracket, 1 plus I, all raised to the power n minus 1, close bracket, all over I, and the present value formula is P is equals to X into 1 minus into 1 plus I, all raised to the power negative n, close bracket, all over I. We're going to utilize this formula to solve problems involving present value and our future value annuities. This information is extracted from the CAPS document 2011, page 42, and our mathematics ATP grade 12 2024 on page 5. Pre-knowledge. So this is what you're supposed to know from your grade 11. So we are supposed to remember, and we will know and make use of the simple and compound growth and decay formulae, where A is equals to P into 1 plus IN, close bracket, plus A is equal, and A is equals to P into 1 plus minus I, all raised to the power n. To solve problem involving different periods of compound growth and decay, which includes the nominal and effective interest rate. So we're going to utilize those two formulas that we use from grade 11 into this lesson, where we remember and we utilize the concept of compounding periods, and we remember how we utilize the nominal and effective interest rates. The baseline activity. So this is the activity that covers the work that we have done in grade 11. So I will give you 10 minutes to complete all of those questions. Right, welcome back, grade 12s. Now let us go through the solutions of the baseline activity. Number 1, the statement reads as follows: Andrew invests 50,000. What amount will his money grow to in 9 years' time if the interest is calculated at 13% per annum compounded monthly? Now, remember that when we are dealing with financial mathematics, we always remember to do what? We always have to derive the data, that is to collect the information from our statement. Now, let us see what is given in our statement. We are told that Andrew invests. So that investment that Andrew is making, he's making it in the present. So that's our present value as we make the investment right now in the present. So he invests currently or recently. What will his money grow to in 9 years' time? So we are looking for a future amount. We want to know, when I put the money of the amount of 50,000 in the present moment, how much will I have in future? So that means we are looking for what we call a future value, and we want to know how much, by how much will this money grow to in 9 years' time. So our period in this case, which is n, is equals to 9. Now the interest rate is calculated at 13% per annum compounded monthly. Now remember that we have interest rate quoted as a percentage. So the first thing that we do, we take that interest rate, we divide it by 100 to get our I. Thereafter, if we can add to this, we remember that we have a compounding period. So when we have a compounding period, always the I is divided by our compounding period. In this case, our compounding period is monthly. It means we divide by 12. So we divide our I there by 12. Now let us go into the solution. First thing, we have to quote down the formula that we need to utilize to make this calculation. So our formula, as it is compound, we're going to copy down the compound interest formula. We substitute into the formula. A remains unknown as I am calculating for A. The value of P, it is given as we are told that N3 invests 50,000. So the present value, in this case, in the space of that present value, we will have 50,000, open bracket 1 plus our I is 0,13 divided by the compounding period of 12. Then we close the bracket, all raised to the power n. N in this case, it was 9. So our n, it is that 9 multiplied by the compounding period. Remember, as we've discussed in the previous lesson, we are saying when we have a compounding period, we divide I by that compounding period and we multiply the compounding period to n. Now we press everything in our calculator, then A is equals to 160,089 and 89 rands, 16. So that is the value of A. Now let's move on and discuss number 2. Now, on question number 2, they are saying to us, what is the effective annual interest rate for 18% per annum compounded quarterly? So in this case, what's happening is we are looking for what? We are looking for I effective. What are we given? We are given the what? The nominal annual interest. How do we know that this is nominal as it was not stated? We can check. Remember, nominal interest rate, when we look at it, the interest quoted, it is different from the compounding period. In this case, our interest is quoted per annual. That means it is quoted per year. So we are saying, if you check, the interest quoted is per year, but the compounding period is quarterly. So this gives us an idea to say the 18% that we are having there, it is what? It is a nominal interest rate. As our quoted interest of 18% per annum, it is different from the compounding period of quarterly. So our nominal is equals to, remember this is I, so we're saying 18 divided by, we divide 18 by 100 and we get 0,18. Now from here, what we do is we quote down the formula that we utilize for this calculation, as we are expected to convert from nominal into effective. So that's what we are converting to. So we quote the formula down, we substitute into the formula those missing values. We can see that I effective, as it is stated there, it does not have a value as we are looking for it. So we're going to substitute it as unknown. It's equals to, open bracket 1 plus, our nominal interest rate is 0,18 all over the compounding period. Our compounding period in this case was quarterly. So quarterly means we divide by 4. So we divide the I by 4 in that case, and we have our M, and our M there, it is the compounding period, which is quarterly. So our compounding period there is also 4. Thereafter, as we are looking for the effective interest rate, what you do is you transpose this one into on the other side, or you utilize the additive inverse where we'll minus the 1 in both sides. Then what we have now is we have effective interest rate is equals to, open bracket 1 plus 0,18 all over 4. raised to the power 4 minus 1. We just punch everything in a calculator as it is, and we get our effective as 0,1925. Remember, this is what? This is I. We are looking for the interest rate. So the word rate gives us an idea to say we must take our I, we multiply the I with 100. When we do that, we will be able to find the effective annual interest rate that is compounded what? Quarterly. So that is all about number 2. Then we move on. Number 3. So in number 3, we have the following. The statement reads as follows. Musi deposit 200,000 into savings account at 6.3% per annum, compounded semi-annually. 4 years later, he adds another 50,000, and 5 years later, he withdraws 100,000. How much money will he have after 7 years? Now, if we remember very well, this is a type of question where we are having disturbances, we are having adjustments or some sort of changes in a way that we are making a certain deposit during the compounding period or during the course of the period. What are we doing? We are making changes. We can see that there was an addition. That is to say, there was an extra deposit, and 5 years later, there was another withdrawal from the beginning of our period. So now what do we do? In this case, timeline is the way to go. Right. We're utilizing a timeline as there are a lot of changes that are made into our the deposit that we made initially. Right. So what do we do now? We are saying we're going to utilize the timeline in this case to collect the data. First thing, we are checking at T0. Musi deposit 200,000. So this is the amount that you deposit at the beginning. So that is at T0. We deposit that money of 200,000 into the savings account at an interest of 6.3 per annum. Now, if we can check, we are saying the interest rate quoted is 6.3 compounded semi-annually. Remember, we convert that 6.3 into 0.63, we divide by 100, and we take that I, we divide it by 2. What is this 2? The 2 is our compounding period, which is in this case semi-annually. So the compounding period, when it is semi-annually, we divide by 2. Now we can check. If you can check the compounding period, it does not change. And also if we check our interest rate, it is the same. So we can say for all of those disturbances, there were no changes that were made with regards to compounding periods and with regards to our interest rate. So that one, we're going to quote it for each and every disturbance to say our I will be the same throughout. We do not change anything there. Now let us see where is the disturbance. They said 4 years later. When they say 4 years later, that is to say at T4. So at T4, when you go to T4, what happens? There was an addition. There was he deposited more money. So he added how much? 50,000. So we put a plus there to show you that at T4, which is 4 years later, what did we do? We added a certain deposit. We proceed to say, okay, the statement reads and says, and 5 years later, that is 5 years from the initial point, what did we do? We had withdrawn a certain amount. So at T5, as we are saying, 5 years later, we have withdrawn. So to show that withdrawal, we show with a negative 100,000. Then we proceed to say, how much money will he have after 7 years? So at T5 was our last disturbance. Then we move from there until T7. So we are looking to find the amount A at T7. Now, how do we find this one? Now, the first thing that we do, we need to check between T0 and T4 as there was a disturbance. Now, how many half years do we have there? Why are we saying half years? Because remember, in this case, we are compounding semi-annually, and every T from T1 to T2, it represents a single compounding period. So we need to find how many compounding periods occurred between T0 and T4. In this case, we just say 4 minus 0, we get 4. 4 multiplied by, which is our n in this case, from T0 to T4, we're going to just say 4 multiplied by our compounding period, which is semi-annually. Semi-annually means 2. Then we get 4 times 2, which is 8. The 8 there is the one we're quoting here to say we have 8 half years. So that means we have made 8, or the interest was compounded how many? 8 times between T0 to T4. We proceed. Let's check between T4 and T5. What do we do? Let's see. We are saying how many years, or what is the period from T4 to T5? It's 1. Just for 5 minus 1. Then we are going to also account for the compounding period. So the compounding period is semi-annually. Semi-annually means multiply by 2, which is our half yearly. Then how many? We have 1 times 2 as 2. So we have 2 half years as it is quoted there. We proceed between T5 and T7. How many half years do we have? We're going to just say 7 minus 5. Our 7 minus 5 is 2. So 2 multiplied by our compounding period. In this case, the compounding period here we are having is how much? Is semi-annually. Semi-annually means multiply by 2. Now, after we do this, what do we then do? We now substitute into the formula. Now, each and every disturbance, you will see in the formula that it will be accounted for. Now, for the first part, from here until here, we are accounting for the initial deposit. That is to say, we deposited 200,000. This 200,000 will grow until the end of 7 years. That is to say, it will move from T0 to 7 years. Then how many times did this 200,000 gain interest? So that's what we are checking now. That's what we are focusing on when we're looking at the end there. How many times we add? It's 8 plus 2 plus. So it's 8 plus 2. In that case, we get 10. Then we say 10 plus 4, we get our 14. So the 200,000 from the moment it was invested, it has received interest. How many times? 14 times. Now, we're saying A is equals to into 1 plus I, it's our interest rate divided by 2 there as it was explained earlier, all raised to the power 14, as the 200,000 will remain in the account until T7. Plus, now this addition it represents a deposit. So we added some amount of money when we are looking at that period. So we added how much? We added 50,000. Plus 1 plus our I is still the same because I did not change in this case. Close bracket, all raised to the power 6. Now, why 6? We are saying, as I put my 50,000 at T4, how many times did this 50,000 receive interest? Or how many times was the interest added on this 50,000? So we check the 50,000 will be put in from T4 up until T7. Then what do we do there? We're saying, okay, from T4 is 2 plus 4, which is how much? Which is 6. So it will receive interest 6 times. Right. Then we proceed. There is another disturbance. We'll account for it. So the other disturbance is the 100,000. So the 100,000 we are saying there was a withdrawal made. So when we make a withdrawal, we are removing money out of the account. So in this case, we have removed that 100,000 shown by the negative there. Now we're saying, okay, minus 100,000 into 1 plus I, all raised to the power 4. Now with the 100,000, remember when I put in 200,000, immediately you must remember that the 100,000 was part of the 200,000. And that 100,000 in the 200,000 was also going to gain interest. So what do we now do? In this case, what will happen is we must remove that 100,000 that was within the 200,000 with the interest that it was going to gain. So it was going to gain the interest for the remaining period from T5 to T7. So how much was it going to gain, or for how long? It was going to gain for 4 compounding periods in that case. So in this case, we are saying we're going to have 100,000 plus our I, they all raised to the power 4. because that 100,000 was supposed to gain an extra 4, so we are removing it with the interest that it was supposed to gain. We press everything in our calculator. Then at the end of T7, or at the end of 7 years, Musi will have an amount of 255,762.75. Let us move on to the last question of our baseline. Now, on the last question we are having, make it deposit 50,000 rands into the account for 10 years. The interest rate for the first 3 years is 2.8 per annum compounded quarterly and 3.2 per annum compounded monthly for the remaining years. How much money does she have after 10 years? Now look at this one. What we are seeing here, we are seeing changes in terms of the interest rate. Remember, any change that we are making or any amendments that we make, what do? Our first thing that we do is to draw a timeline. So that means we take all this information, we populate it within our timeline. Now let us populate the timeline. We are saying make it deposit 50,000. So the amount that we deposit presently, it is what? It is at T0. We are putting in 50,000 right now. And we are putting it for a period of 10 years. So it's from T0 when you put it in until T10. Now the interest rate for the first 3 years is 2.8. So from T0 to T3, we have a certain interest rate of 2.8. So that rate, remember, we convert it into I. We say 2.8 divided by 100. We get our I there. Because there is a compounding period, so our I will be 0.028. Because there is a compounding period, what do? We need to account for that compounding period. And when we are looking at I, with that compounding period, what do? We divide by 8. So quarterly means how much? We divide by 4. So that means our I then will be divided by 4 to account for the compounding period of quarterly. And now there is another change. They're saying there's a 3.2% per annum compounded monthly for the remaining years. That means from that T3 until T10, which is our end or the end of our period, we are saying there is a new interest rate of 3.2. Number one, remember, it is given as a percentage. We divide by 100 to get it in decimal form, to get it SI. That is to say now we're having 0.032 all over the compounding period. What is the compounding period for this new interest rate? We are told that it was compounded monthly. When we are compounding monthly, what are we doing? We are dividing I by 12. We divide I by 12, and this is what we have as our I. Now our I was 0.32. Then we divide it by 12 as it was compounded monthly. So this side is monthly. This side is quarterly. Right. So what we do now in the following is we proceed to check. All right. From T0 to T3, how many times did I add interest to this amount? Now that is to say, how was N affected? Now we're saying from T0 to T3, how many years do we have there? It's 3 minus 0. How many years? We're going to have 3 years. 3 multiplied by, this is, or during from T0 to T3. What are we doing? We are compounding quarterly. Quarterly means multiply that N by 4. Then what do we get there? We get 3 times 4, which is 12. That's why we have our 12 quarters quoted there. Then we proceed to check, okay, how is N affected this side? N is affected to say from T3 to T10. How many years do we have there? It's 7. Multiplied by the compounding period. The compounding period from T3 to T10 is how much? Is 12, as we are compounding monthly. So we'll multiply 7 by 12 and we get 84 months. Now we plug everything in the formula. We are saying, because now we are talking about the change in interest rates. When we are talking about the change in interest rates, we are multiplying the two differences in interest rates. Unlike the one we had, or the previous example we had, in our previous example we had deposit and we had withdrawals, where we use operations like a plus and a minus, plus for deposit, minus for withdrawals. However, when it comes to the change in interest rates, we are saying we will multiply the changes of the interest rates together. Now we are saying our present value that we had, we put in, it was 50,000. So we'll have 50,000, open bracket, 1 plus our I there as 0,028 all over 4, close bracket, all raised to the power 12. The power 12 there is our quarters that we found there, multiply by the new interest rate for the remaining period. What was the new interest rate? It was open bracket 1 plus 0,032 over 12, which is our I, all raised to the power 84, which is our N in that case. Then we get our future value as 67,994,87. Now let us focus on today's lesson. So our today's lesson, we are focusing on annuities. Now annuities, what are annuities? An annuity is a series of equal payments made at regular time interval. So it's a series of equal payments. Now if you go back a bit to grade 11, what we did in grade 11 is that we put a certain amount in the, let's say it's an investment, we put a certain amount in our account, we let that amount to grow over years. That means you put in 50,000, we leave it there, we let it grow for a certain period of time. Now when we're talking about annuities, in this case, what are we doing? We are having a series of equal payments. That is to say, we are making regular payments into our investment. In other words, we put in a certain amount, maybe if it is per month, we put in 500 rands per month, 200 rands per month, it doesn't matter. So in this case, what we're doing with annuities, we're saying we are putting equal payments monthly. So here we are saying we are putting money per month. It's unlike the previous activity, as I've explained, to say we were just putting money in the account, we let it grow for a certain period of time. Now also annuities, remember, it also involves your loan repayments. The examples include is regular savings, to say you put in 50 rands per month to a certain goal, so we are making a certain savings regularly. When we say regular, the regular there, we will look at compounding periods. That is to say that will take place for a certain compounding period. So if you say we are putting payment quarterly, that means you put in that 200 rands after every 3 months. So we're looking at retirement annuities. We are looking at the repayment also, to say you will receive a certain amount of loan and you are required to make a regular payment or repayment into that vehicle or home or any form of loan. Now annuities are calculated using two formulas. One of them is the future value formula. Now the future value of an annuity, it is defined as the collective value of all payments made at regular intervals in order to save money. Now with the future value, what are we doing? We are moving to the future. That is to say, we are depositing money regularly into the future to reach a future goal. So we put in money today and we expect this money to grow in future. So here we are talking about future value annuities. Then we have another way of calculating annuities, which is the present value formula. How do we calculate using the present value formula? Here we are saying the present value of an annuity is defined as the collective value of all payments. So it's all payment made at regular intervals in order to pay back a loan. So with the present value, we are saying you will be given money first and you are expected to make regular payments to do what? To repay that amount that was given to you. So it's present value as you receive the amount right now. So we get that money and we need to make regular payments into repaying the money as it was loaned to you. Future value, remember, we are saying we are saving for the future. Future value, don't have the money present. What you do, you put in money monthly and you will get a certain amount in future. Present value, what's happening? You are given a certain amount of money, or you are loaned a certain amount of money, and you are supposed to make the regular payment into this amount that you have or you have been loaned. That is to say, in this calculation of present value, the money is first received. That's what we meant. So we are saying we give you the money and you pay it back using regular payment. Hence, we are under annuities. Right, let us move on. Now, annuities, we must remember that we need to remember, or we need to know the following conditions for the annuities in grade 12. Now, let's say the annuity formula in grade 12 are applied under the following conditions. So these are the conditions of applying annuities. Now, this is to say we're going to apply annuities where payments are equal. That means you are making regular payments that are equal, 500 rands per month until we are finishing to pay off the loan, for example, or 500 rands per month until you reach your goal in future, which is future value. The second condition, it is that it must be provided that all the payments are made at regular intervals. So that means the payments that we are making in this case, it must be made at regular intervals. If you are making a payment monthly, the payments must be made monthly, every month. You can't put money now, this month, and next month you don't put it, maybe you leave it for whatever time, and you put it maybe 6 months later, or also not. So here we are saying there must be a certain regular interval. If you are compounded monthly, you will put it in monthly. In a case whereby you are not, we are not talking about regular intervals, we'll discuss this on our next lesson. This is where we're going to talk about deferred annuities. Right, the interest rate in this case will remain fixed. Now, in our previous lesson, and we have seen with our baseline that we just marked, to say the interest can be changed. So luckily for us in grade 12, we are saying the interest rate will remain fixed. So we'll work with the same interest rate. So we are saying the compounding periods for the interest is the same as the payment intervals. Very important. This one is to say, if you are compounded monthly, that means you must make payments monthly also. So if you're compounded semi-annually, that means the payment must be made semi-annually. So there must be a correlation between between the compounding periods and our payment intervals. So we are saying we are not going to work with a situation whereby you are compounded monthly, but you want to add or you want to make payments maybe quarterly. No. So that is to say, in this case, or on this bullet point, we are saying the compounding periods, we are saying same compounding period for the same payment. Monthly compounding period, monthly payment. As simple as that. Oh, that is the emphasis there. If payments are made monthly, the interest rate will be compounded also monthly. Now, what are future value annuities? Remember, future value annuities is used whenever the regular payments are made first. In this case, we make a certain payment and the total amount is collected later. So in this case, we are making a regular payment and will collect the total later on. Now, when do you collect this total? The total is collected immediately after the last payment. So this is how we show this in our timeline to say at T0. When we talk about the future value annuities, it will relate mostly to investment. So at T0, if you open investment account, you are expected to make a deposit immediately. The X there, it is to show that there was a deposit made at that point. So we open the investment now at T0, we make the immediate payment. Then we go T1, T2, T3, T4, and T5. Now we get to T5. When you go to T5, T5 is at the end. We put in the last amount first before we can get our amount, or we can collect that amount. So with future value annuities, we make the payment immediately and we collect our payment after the last payment. So that is what we are doing. We are collecting those payments into the future. Now, the timeline that we're going to utilize under annuities, it will be a bit different from what we did on our baseline and on our previous lesson and in grade 11. So how is it different? With the previous one, our T1 and T2, T3 were representing number of years. But when we come to annuities, our T1, T2, from T0 to T1, it is a one compounding period. So this period, it represents a single compounding period. What do we mean when we're saying a single compounding period? If the interest is compounded quarterly, that means this is how many? This is 3 months. So that gives us 1 quarter. So if the interest, for example, it is compounded monthly, just making an example, this from here, between any T1 and T2, from T1 and T2, what are we saying there? We are saying from here to here, what we'll have is the following. It's going to be 1 month. So this is when the interest is compounded monthly. Now, we're going to take a break and we'll come back to discuss the future value annuities examples.